Another 7th grade advanced class. Let's go ahead and knock this one out. 8.3, we're going to find the products. I'll do all the odd ones, of course, so let's start. When I'm distributing properties here, I'm going to take 4x times x, which will make 4x squared, and then 4x times negative 3, which would be negative 12x. We went over this in class together. Number 2 is for you to do. Number 3, if I have negative 3p and I multiply it to p to the second power, that'd be negative 3p to the third power. We know this because negative 3 is being multiplied to that invisible 1 that we know is in front of p. Anything multiplied to itself is itself. And then p to the first power times p to the second power is p to the third. Next, we'll take negative 3 to the p, negative 3 times p, and multiply it to positive 6t, which will give us, well, negative 3 times 6 is negative 18. And then we'd have negative 18 pt because you can't multiply p and t together. Then you have negative 3p times negative 9. A negative times a negative is a positive, and negative 3 times 9 is 27. So this should be positive 27p, bringing up the rear. So negative 3p to the third power minus 18 pt plus 27p would be our answer. Number 4 is yours, 5 is mine. It said the red figure is similar to the blue figure. Describe the similarity between the two figures. I can see this as a direct reflection because I'm going off the x-axis here. Each one of these is one away from that x-axis, and each point to the shape is directly opposite of it. So this would be a reflection off the x-axis. All right, number 6 is yours, 7 is mine. It says find the quotient of powers. Write the quotient in repeated multiplication form, and then write the quotient as a power. So if I'm doing this here, I remember that when my number is bigger on top, I can subtract the bottom number from it. Exponent, I should say, since these are the same base. And remember, the base has to be the same to do this type of stuff. So this would be 6 minus 2. If I was going to demonstrate this, I guess the best way to do it would say, since this is a positive 2, I'll minus 2 from here, and I'll minus 2 from here. This is going to give us negative 4.5 to the fourth power. And so we would have negative 4.5 times itself 4 times. And then as a quotient of powers, it would be negative 4.5 to the fourth power. All right. As you can see here, we've got 6 negative 4.5s on top, 2 negative 4.5s on the bottom. That's going to give us a negative 4.5 to the fourth power. All right, 8 is to do it. For 9, it says dividing powers with the same base, simplify the expression, write your answer as a power. Well, we know the bigger number's on top, 9, so 9 minus 4 will give us 5. This would be 5 to the fifth power. 10 is for you to do. Number 11 has a 4 on the top, 1 on the bottom with the same base. So I could say 4 minus 1 is 3. This would be negative 3 to the third power. And remember to put that parentheses around the negative and the 3 because the negative also is getting multiplied 3 times. Number 12 is for you to do. And then we have number 13. We got 12. D is a base on both the numerator and denominator, and 12 for the numerator, 5 to the power of 5 for the denominator. 12 minus 5 is going to give us, I believe, 7. So this should be D to the 7th power. Over here on number 15, we have negative 6.4 to the 8th power over negative 6.4 to the 6th power. Since the base is the same, I can say we're going to have negative 6.4 to the 8 minus 6 would be to the 2nd power. Now, they don't show this a lot on any of these, actually. But if the bottom number was bigger than the top, then you would move the top number to the bottom number, since the bottom's bigger, and you would put a 1 on top. We know this because this number here, I'm going to demonstrate this really quick, is really over 1, right? Because anything over 1 is itself. So when we do it the opposite way, you would put 1 on top and the number on the bottom, always to the positive power, never to the negative power. All right, so 16 is for you to do. Let's go to number 17, which is mine. Your friend simplifies the quotient. Is your friend correct? Explain. Where it says t to the 14th power over t to the 7th power would be t to the 14 divided by 7. This is incorrect. We're going to subtract, not divide. So this would be 14 minus 7, which would be t to the 2nd power. The exponent should be subtracted, not divided. All right, I've got number 19. It says, write your answer as a power. Well, remember when we multiply exponents with the same base, we add. So this would be 4 plus 5, which would make 9. And then when we divide it away, we subtract. So 9 minus 3 would be 6. This should be p to the 6th power. Number 21, we have, again, the base is the same, so we can add these exponents when they're being multiplied. 8 plus 6 is actually 14. And then subtract 8, because we're dividing now. That's going to give us, well, z to the 6. We know this because anything over itself is 1, really, right? So this is going to be z to the 6th power. Number 23 says w to the 13th power, and it has 4w to the 4th power times w to the 2nd power. We're going to take the w's and combine them here. This would be 4 to the 6th power. Then we know 13 minus 6 is 7. So what we're going to have here is going to be w to the 7th power on top, but 4 stays on the bottom because we're not dividing 4 by anything in the numerator. And now you can see what I mean by sometimes there is going to be a denominator, not a numerator. So we have w7 over 4, period, no variable at all. Sorry about this one. Looks like I gave all these answers before I got to it, but I will explain it. Number 25 says simplify the expression, write your answer as a power. We're taking this negative 4 base and we're multiplying 8. Well, we have 8 and 3. Since we're multiplying these and add the same base, we can add these. 8 and 3 make 11. And then we'll add these down here because we're doing the same thing, and that's 6. And 11 minus 6 is going to be 5. I'm just going to write that out so you can see where we're coming. This would equal negative 4, in parentheses, to the 11th power, and that would be over negative 4 to the 6th power. And since we're dividing now, we subtract the exponents. 11 minus 6 is 5. All right, let's go to number 27. We have d to the 4th power times d to the 8th power times d to the 7th. We add all these exponents together. I know 8 and 7 make 15, and 15 plus 4 make 19. So this is going to be d to the 19th power. And then we're going to have d to the 3rd times d to the 6th. That's 9. So that's d to the 9th power. And we know 19 minus 9 is 10. So we have d to the 10th power as our answer. Number 29, again, we add the top. The bases are the same, so 13 and 5 make 18. So this would be x to the 18th power. That's going to be over x to the, 8 plus 4 is 12. Now we take 18 minus 12, and that makes 6. All right, let's move on. This says simplify the expression. I'm going with 31 since it's an odd one. We see this is going to be m to the 4th power, but also n to the 4th power. So this should be m to the 4th power over n to the 4th power. That exponent gets multiplied to everything in the parentheses. Number 33, b, since we have a power to a power, b will be to the 6th power, while 7 to the 2nd power. And 7 times 7 is 49. So b to the 6th power over 49. Number 35 is s to the 4th power, t to the 5th power. So s is going to be to the 4th power, and since this is an exponent to exponent, t will be to the 20th power. S to the 4th power over t to the 20th. 37 is mine. A box is in the shape of a square prism. Find the volume. When finding this, I realized since this is a square prism on the bottom, they're basically saying that this bottom shape, all the sides are going to be the same, right? So if this is 2 over 3h, this will be 2 over 3h. And of course, we know the volume for a box is base times height times length, or width times length times height. So we're going to have 2 to the third, I'm just going to put over here, 2 to the third h times 2 to the third h. Well, 2 times 2 is 4, 3 times 3 is 9, and h times h is the second. But then we have another h. So really this is going to be 2 to the third h times 2 to the third h times h, right? So we're going to have h to the third power here in the end. And that'll give us 2 times 2 is 4, as I said. 3 times 3 is 9. We should have 4 over 9 h to the third power as an answer. And there it is, 4 over 9 h to the third power. All right, let's go to number 39. 39 says, discuss mathematical thinking. Let A and B represent rational numbers. And let M and N represent positive numbers. Remember, they're positive numbers. Tell whether each of the following is true. Explain your reasoning. So it says a to the m power over a to the n power equals a over b to the m power. Well, that will only be true when a to the n power is going to equal b to the m power, right? Oh, I'm sorry. It looks like I did 38 over here for b. So it looks like you got an easy answer for b. You'll have to find out a. And it is true when b to the m power, as I said here, is equal to a to the m power. On B, we're going to have, I want to make sure I didn't do this alternating. Hold on. Because each one of these is a question. I'm pretty sure we're going to have, okay, so I did give it. A to the m power over a to the n power is bigger than, look at that equality sign, inequality sign, greater than a to the m power over b to the m power. That's only going to be true because remember, a and m, this is going to be a and m as well. So we're going to need a denominator that's going to be, since this is going to be bigger, right? We're going to need a to the n to be smaller, a smaller denominator, okay, than b to the m. True when a to the n is smaller than b to the m. And let's see, C says a to the m over a to the m is going to be smaller than a over b to the m power, and that's only going to be true when a to the m power is greater than b to the m power. All right, let's go on to number 40. You have number 40, I have number 41. It says find the missing value that makes the equation true. Well, let's see, when we make this true, we see that we're going to have y to the third as an answer. I just have y to the third over here times y to the fourth, so that's going to be y to the seventh. So I'm just going to put that up top to remind me. All the top here should be y to the seventh. And so what do I have to add to 2, right? That's going to give me 3. And I know 7 minus 2 is 5. So I would need another 2 over here, right? Because then this would be 4, and 7 minus 4 is 3. So yeah, this is basically 7, this is y is going to have to equal y to the 2 power. And then this would be y to the 4th. And 7 minus 4 will be 3. So yes, when n is equal to 2. All right, looks like the rest of them are for you to do. Good luck, and we'll grade these in class. Have a